Okay, and here we continue creating this game. And so this is a console programming, and I'm gonna continue creating this game. This time I will be creating the game engine for this game, and that will be the task next. It doesn't have a game engine yet, so let's see how it goes, and I will create the game engine. So at the moment this is how it works. Compiling, and then compiling, and yeah, so here is the current version. Excuse me. Yeah, current version, like that. Oh, just a moment, just arranging this. How does it look? How does it look? That just a moment. I need to set up the system. It looks good. Is it okay now? Looks good. Pretty cool. I need to push it a little bit up. It's okay now. Little bit like that. I can make it, push it a little bit down like that. Yes, more space. Okay, I think it's okay now, so I can continue. Just checking how it looks from my mobile phone. Check that it looks good. Yeah, it looks pretty okay. Okay. Yep. Okay. Looking good. So game engine. So where is my game? Where my game is here. So currently I was able to put the Unicode. Unicode works like that. So this is the current situation. Obviously it already works. It's not about the question does it work or does it not work, or today's change is not gonna actually change much this behavior, but we just create a better structure, and we create a general game engine that we can create other games later on. So it's not only about this game, the snake game, but so we can use this same platform to create other games easily, other console games. So I'm just creating a very simple game engine to start with. Doesn't need to be complicated. So this works really well already, actually. I mean, it works really well, and I was able to get it working yesterday. I found the Unicode values, and I can show where the Unicode values are if I just find them. Where are they? U something. Where did I put them? Here they are. Yeah. So for example, this is the left hand side Unicode value for the wall, and that's the right side value for the wall, and so on. Last time when I was running this, doing this live stream, I struggled to find these, and I got stuck actually, and the video became very long. But this time I found them. After the video, I found these characters, and it's looking just okay. But there's some gaps, but it's okay. It looks okay. The colors could be changed, not so that maybe the snake can be green or something, and or black. Maybe I can change the colors later on. It works really well, really fluent, like this. It remembers the direction and stuff. Picture. Oh, thank you. Oh, really? Oh, So the video is 144. Are you sure? Let me check on my mobile. That's a good point. Let me check my mobile. Let me double check that from here. How do I check that? No, it says 480 here. On my mobile phone it says 480. But that's an interesting question. Why is it higher quality, higher pixel quality? Let me try. It's 480. 480. Is this normal? Actually, I'm not familiar with this thing. It says 480 here. Maybe you can change it if you go to settings and I just tried on my mobile phone. It says 480. Yeah, it might be. And I don't know. Maybe is it that the live stream has worse quality anyway? I don't know if it's because it's kind of default. I don't know. Anyway, well, 480 should be enough for this kind of purpose. Doesn't need to be perfect here. Yep. Okay. So now I'm gonna do now the game engine, because this one doesn't have a game engine. Basically, what happens here at the moment is that I'm just running. I have this snake game, and I'm just calling the run the game, and I'm calling it from the main. I create the snake game, and then I say that run the game, and then the run the game is gonna start the game loop here inside, and then I'm gonna do update input. Update input, update logic, and then I'm gonna render. So I keep doing this, and I'm doing it like even intervals. So like every 60 milliseconds I'm doing this. Now this is not the best way to do game programming, that you have just fixed 60 milliseconds. It actually works here really well. But I mean, if you do just general game programming, this is not the best way to update, that you have a fixed time like 60 milliseconds. It works really well in this case. I mean, there's no problem here. If you look at that, it works perfectly. Actually, there's no need to change this one. But the purpose of this video is not about the snake game. It's about all games. Because later on, we can use the same platform to create another game. And in that case, we might need better loop, better way. Okay, so I'm gonna create now the game engine. I already started, so I created this class game engine, and then there's gonna be initializing the game, and then there's gonna every round update, render, and then when the game is over, we're gonna have the game over call, and this one starts the loop, starts everything, and obviously the start. Here's the start, game engine start. It will initialize the game, it will run the game loop, this one, and then it will call game over. And so now I need to how do we change this current game so that it's gonna use the game engine instead? And I already thought about it. So at the moment, this is what we have. We have the snake game here. So the only thing I think we need to do is that we need to just inherit it. Oh, my own language is there. So we need to inherit it from that game engine. Okay, so I'm gonna inherit it from the game engine. I think that's the way to do it. So I'm gonna inherit it from the game engine and include that game engine. Okay, and taking time. Yeah, there it is. Okay, so we are inherited from the game engine, and now we need to do all of this stuff. So I need to maybe copy all of that stuff. So we're gonna create those 4 functions here now. I think we can put it in a protected section. Yeah, we can put it in a protected section because it's a private for this class. The main doesn't need to know about this one. Protected, and so we're gonna implement all of these functions here, and so let's start now cracking. Well, there they are, and let me implement one of them. For example, let's just to initialize function. So I'm gonna implement this one just to check that this thing starts working. So I'm gonna implement that like a very empty one. Just so going here, and let's put that implementation here. Update, initialize the game, and well, we actually we have an initialization. Yeah, we have initialization section here. This section here before the while loop, we need to do this kind of stuff. This is the game loop. So we're gonna change this. We're not gonna do this game loop here. The engine is gonna run this one, but this section we still need to do this one. So I think this one goes very well to the initialization section because this is the initialization code, the starting code, the first code. Okay, so initialize. So let's start cracking. So I'm gonna go now to the main, and instead of starting the snake game, I'm gonna include no, it's a snake game. Yeah, snake game, but instead of saying run game, I'm gonna call it's start. Well, it's the same thing basically, but I'm gonna just call the start, and it should start the thing. So okay, start. Now the start is gonna go to, it's gonna go here, and it's gonna call initialize, and then it's gonna call game loop, and so on. At the moment they are empty, so but I'm just gonna test quick that it comes here. Well, I can do the render there, isn't it? Well, I can do this section totally, isn't it? I can do this section. Why not? I can put that there in initialization section, so it should show the first screen now. It should draw the beginning screen. Okay, yeah, that's interesting to see if it works. So let's start. Yes. Okay, looks good. Let me compile. Yeah, this is pretty interesting actually. The last video I made was boring because I got stuck so much, but I think now this is going fluently. We know exactly what we are doing. So okay, so let's see what happens. Yeah, it works. We got the starting screen, but it doesn't go further from here at the moment, so I will delete it, which means that I need to press, what is the key I need to press? It was the X, I think. Oh, ESC. Yeah, ESC, yeah, you see. So you press S key, it closes the start screen. So now we need to start adding more. So the initialization worked, and now we need to implement next. We need to implement this update function. So every time the screen is updated, like 60 times per second, it's gonna update it hundreds of times per second. Basically, it's gonna call this on every frame. So this is the big function. updating the game logic. So the game engine will call this update each time one game moment needs to be updated. It's the smallest time in the world. So this is kind of the smallest time in this game world. And it will be calling this one like 100 times per second. So it's the game loop, it's the content of this. It's the content of this game loop basically here. Okay. So, and I already created this game engine loop. I put it here, and I have this sophisticated code here to do the fixed time step. Actually, I'm gonna explain, people who are watching this video, I'm gonna explain how this fixed time step works here. Okay, I'm gonna actually draw it for the people who are watching this, what this section is doing. Okay, let me draw that to make a nice video. So what happens here is that we have this. This is the we're gonna have a fixed time step, which means that we're gonna update fixed time step. Okay, it means that we're gonna update the world, the game world, on fixed intervals. The physics will be updated on fixed intervals. Okay, so this world doesn't know anything else than fixed intervals. Let's say it's let's say for example 10 millisecond. Okay, and this would be 20 millisecond. This would be 30 millisecond, 30 millisecond, and so on. 40 millisecond. Okay, so this game doesn't know anything between. You understand? It doesn't know that point. The game only knows this game world. It only knows these points, and it will update the situation at these points. Okay. And let's look at the real life. So this is the imaginary game world based on sleep in while. Yeah, if you do if you sleep, if you do the old way, like a beginner's way, you will use sleep, isn't it? But I'm doing it better than that here. You could sleep. You could sleep. That's one way to do it. You sleep 10 milliseconds and then you sleep another one, isn't it? But it's not the best way to do it, because sleeping is, because the program gets a little bit stuck, and sleep is not accurate also. Sleep is not accurate. Okay, but some people do like that. Yeah, so basically but the idea is the same, that you are sleeping here then, and then you do that. Okay, the real world. So this is the imaginary world, imaginary game world, and then we have the real world. This is the world which we are seeing, the real world. Okay, in the real world, what happens is that, for example, let's say that we update here. Okay, we are coming here. You see what I mean? We didn't hit this spot. We are updating let's say that we are updating the screen over here. And now the question is that, because we went a little bit over that point, what are we gonna do now? Because we are too far away, we can't update this guy. We can't go there because we are not yet there, and we passed this point. So the question is that, what are we gonna do at this point now? Because there is a little bit extra here. We can do this update, but then there's a little bit extra here. So what are we gonna do? So what we're gonna do here is that we're gonna only update this section. We're gonna update this 10 millisecond. We're gonna tell the game that please update this position. Okay, and that's it. But we will save this thing. We will save this. We will accumulate this one. We will add it to we will accumulate plus equal. We will add this one there So next time when we come to the game loop, we will use this section then. We will consume this later on, okay? Because we can't lose the time. We can't throw this to bin. We have to use this, but we can't use it yet, okay? So let's say that, yeah, so next time it comes here and so on. So let's say that, so this was the first thing, okay? So let's say that the next time it comes here actually. Very far away, very far away. Let's say that in theory happens like this, that it comes here. This is the next updates when we can call the update. Now there's this one and this one and this one. There are three of them kind of missing here. So if this one happens, we will update two fixed steps. This one, sorry, three actually. This one, and this one, right? Yeah, because we added this section there. So now we can update this one. We can update three time steps. Okay. We can update now. We update 3 time steps, and then we will draw this situation. We will draw. Okay. We will update the world one by one. First this one. 1, 2, 3. We will update these in this order. We will update the world according to this section, then we will update the world according to this one, and then according to this one, and we have a little bit left over here, but we will do that next on the next round. So we will save this one again, and the world is now here, and then we will draw the world kind of according to this one, kind of. We can also add this one to the drawing if we want, and that's another story. I'm not gonna do it maybe in this video, but the idea is that we will update the world. We will draw the world according to this one. Okay, so this is what I'm doing here. So I'm not sure if I'm gonna go this step by step here, because I might do another video about this later on. But basically what I'm doing is that I'm taking the current time, and then the loop duration is the time it took for the one loop. You can forget this one, that's not important, this one. And then here, time not processed. So here I'm accumulating that how much time we need to process, how much time is not processed yet. Okay, and then here we are calculating it, how many steps we need to update. How many steps we need to update. Like for example, in the last section we needed to update these three steps. So how many steps we need to update. So in that case, the for loop will be doing 3 steps. And then here we say that okay, this is something else, don't worry about that. And then here, and then we need to remove that from time not processed. We need to, because we just updated those 3, so we need to remove them from the accumulated time. We need to remove them because they have been done. And then yeah, and then if we update it at least once, if we run this, if we call this update at least once, then we're gonna do the render. Okay, because there's no point to render if we didn't update anything, right? So if the world was updated, then we're gonna render. Okay, cool. I never tested this. I did not. Well, I've done this many times before, this kind of thing. So it's not the first time. So it might work. I haven't tested this. So let's see what happens if I run this. But so let me go back now there. So this is the snake game. So now this is the tricky part, that we need to start cracking this thing. I'm just gonna be brave, and I'm just gonna do all the coding straight away, and then let's see if it works. So this is the section we need to run there. So I'm gonna copy this section. Yeah, copy that section. How about the keyboard? Oh, here's the keyboard. So here's the keyboard. Sorry, there's the update input. Yeah, it's there. Okay, no problem. So I will now copy this code. this is the old loop code. So I'm gonna copy that and gonna paste it in update section. Okay. And let's see what we need to change here. So there's the keyboard update. I think that's fine. And what is this? Current frame time. Okay. Yeah, we don't need to do this. Yeah, we don't need to do that. Yeah, we just need to call the update game. Oh, we need to only do this one actually here. Yeah, it's that simple, because all of this stuff has already been done in the game engine. It's done here. So we don't need to do any of these calculations here. So the only thing we need to do here is to update the input and then update the logic, isn't it? Yes. Yeah, I think that's all we need to do here. So I'm gonna copy that update game logic there, because the render is done elsewhere. And I think that's all we had to do here. So I'm gonna comment that out. Okay, so that's the update section. And then we have the render section, and the render, where's the render? So here's the render. So let's see what we need to do there. Okay. Okay, in a render section we need to, I'm just looking at the old code. I'm calling the render 2, the version 2 here. So I guess I just need to kind of call that here. That's all, isn't it? So my old renderer, this is the old render function. So I'm just gonna, at the moment I'm just doing like that. I'm just calling the old render like that. And well, that's pretty much it. But there's one important thing which is definitely missing here, and it's the movement, it's the speed, because the how much the something is moving, it's the time multiplied by time what am I doing? So if we know the speed, the distance will be the speed multiplied by the by what? What am I talking about? Yeah. It will be the distance we need to move. It's the speed multiplied by the time. Yeah. That's how much we need to move. Speed multiplied by the time. That's the distance. That's physics. Okay, so let's go and do that next. And that's gonna be an update. This is the oh, that's a render. So here is the update game logic. So this in this section we are not moving anymore. We are not moving one square to the left like before. Now we need to calculate that how much we need to move to the left. And that will be the time multiplied by the speed. So it's going to be a little bit more complicated now. We are not just moving one square. We need to calculate that how much we need to move. Okay. So for that, I already thought about this. We need to have a couple of things. We need to have, I think we need to have a speed here now. So in the snake game, I'm gonna create two variables here now. And one of them will be, I think it's double speed. I'll just call it speed for now. Okay, and start, well, what would be initializer? Well, let me put that speed actually here. So the speed will be, well, I don't know. I really don't know what kind of figure, but that's not, we can test this. Maybe 10. Let's try 10 or 1 or I don't know. We will see soon. We will see. We will test it and we will look at, do we need to increase the speed or slower? We will see it. And then the other thing is that we need to have the position in floating numbers. This is very important because at the moment the position is an integer value, because the position is the coordinate. But now we need to have much more accurate. We need to have, let me draw it. So maybe I can delete this. I can delete that. So at the moment, here is the board at the moment, and if the snake is here, it will be, the position will be 0, 1, 2. It will be 2, 2, 1, isn't it? 2, 1. Okay, that's the position. But now it's a different now. Now we need decimal numbers, because remember that this snake is now moving constantly down. It's not moving one square. It's moving decimal numbers. So it could be something like 2.1 and then 1.3, for example. So now it's going to be a decimal number because it's moving slowly now. It doesn't move per square. It's moving gradually. Okay. So we need to have a position stored as a decimal number. Okay, I already thought about this, and I think that's the way to go. So I'm gonna create now one of those decimal numbers. Okay, so we have this point here, but this point is not. This point is an integer point. I could create another class here, which is a float point, right? To keep things simple. Should I do this? On the other hand, we are only using it once, so I don't think we need to bother going there. Too complicated, right? I'm just gonna create two doubles here, and it's gonna be the snake position x, okay, and snake position y in decimal numbers. Okay. I think that's needed, isn't it? Wait a second. Yeah, I think that's needed. Let's go and think about this. Yeah. Oh, that's actually the head position. Very carefully, it's the head position. Okay, I will draw again. The logic is this one, that let's say that the head of the snake is here at the moment, and here is the let's say that the snake is like this. Okay. The logic is like this, that the head is here, and let's say that the snake moves just a little bit down. Okay. We will not move the snake until the snake hits this, goes over this one. Okay, you understand? We don't move, if it goes here, we don't move it yet. We move the snake when it passes this integer value, which is 1, 2, 3, 4. When it passes this number 4, then we will move it over here, like that. Yeah. So we don't move the snake until it touches next integer value. Yeah. I think that's the logic. That's my feeling. And when we hit that next integer value, and then we will move that. Then we will move the snake, and we only need but integer, right. But with integers, you can simply, if you just say you have if I say 1.34 and I just say int, it will automatically give you the it will cut that 4. So yeah. Okay, so let's do this. So we only need to worry about this head, because the rest of the stuff already works. We don't need to worry about the body, because the body already works. So actually I'm going to change this name. I'm going to say snake head position. Okay, let's be accurate. It needs to be snake head position. Okay. So let's try to implement this one. Okay, so Okay, so this is the critical moment now. Let me think. Okay, so I'm gonna ask the speed now here. Okay, so sorry, the time, and I already created a function here which is called get fixed delta time. Okay, because we are always moving fixed delta time, like 10 milliseconds. We are always moving fixed time here. So auto delta time equals to get fixed delta. So this is the time we need to move. This is the time we need to move. Okay. And okay. Okay. Just a second. Aha, yeah, the movement needs to be happening here. Okay, so I need to remove the old code. Okay. And now we need to move. So if we are going up, if we are going up, well, this is just my feeling at the moment. I might be wrong a little bit in some details here, but let's go and test this idea. Okay, it's sometimes difficult to know exactly, but let's test this idea. So if we are going up, in that case we need to deduct the y value. Okay, so I'm gonna go and take the y value. Okay, and so the new y value will be minus equal, and then we need to say the delta time multiplied by the speed, and that's the speed. So we're going up a delta time amount and with this speed, delta time multiplied by speed. Okay, so, and I was just thinking that one more thing I need to change here is oh, what is wrong? Speed double. Aha, it doesn't like that. It's not defined. What do you mean it's not defined? It is defined. Snake game. Is undefined. That is not true. It is defined here. What is happening? That doesn't like that I'm saying. No, it can't be this one. Oh, now it accepts it. What happened? Anyway, it doesn't matter. It works now. So, okay. So, one more thing, better to straight away, that we need to initialize the head position at the beginning of the game, because at the moment it has no value. So I need to initialize the head value, and let's think about that. Where do we do that? Let me think. It's when we create the snake first. We need to set that value there, I think. So where is that? There is the initialization, and where do we do that? Yeah. Here is the creation of the snake. Here is the creation of the snake. And what am I doing here? Start point Okay. So that's the start point, and I'm adding, and I think the head is at the last point. Yes. Yeah, the head will be the last body part here. Okay. So pushback, it will be the last one. So it will be the back, isn't it? It will be the back, right? Let me try. I think I already used that back. Okay. Yeah, there it is. The back is the head. The back is the head. Okay. So I need to ask the back there, and I need to, yeah, here. I need to ask the back, which is the head, and then I need to set these values accordingly. So the head will be I think it's just the back, and then X, yeah, the back and X, and then the Y will be Y. Okay, so the head, now the head is pointing to the real head. So now it's synchronized with this one, and let's see if this thing works. So now okay. There's a, okay. So back to here. So the Y is minus something. Okay. Okay. And let me do the other ones as well straight away. So this will be X will be yeah, like that. And that will be plus. And then this will be minus, and that will be plus, like that. Okay. Y, X, X, Y. Yeah, I think it's correct. And now, okay, here at this point, now we might have that decimal. We might have 1.3. So now we need to check. Now we need to check that did the mouse move? So how do we check that? Let me think. So if we are at this point here, we need to move. We need to move the head there, and I guess we need. I guess we can keep this. I guess we can keep that. Keep here. But what if I turn this thing? What happens if I turn? If I turn it. If I turn it, then this vertical value, I guess, should. What happens to this one if I turn it? If I keep going down, this decimal number can stay here. Yeah. I know. Yeah, I know. Yeah. You need to check that. But I'm just thinking that if this head turns to the left, like that, what happens to these values? Do we need to initially put this back to the 0 kind of? Yeah, I think that needs to be done, because what I'm thinking is that if the head is here, and then so the head is, it's going down, but what if the head is turning to the left? I think in this case we need to initialize the float value needs to start from here. Whatever it was before, it needs to adjust and go there. Oh, I know. We need to look if the snake is indeed, if the snake is turning, we need to initialize those values. But if the snake did not turn, then we will just keep doing this one. So okay, so now here I need to calculate now here integer new head, let's say new head integer value equals to integer x equals to and I'm gonna take this one and I'm just gonna cut the values. So static cast because if we are changing the decimal to integer, it will automatically just cut the integers out, sorry, the decimals out, which is exactly what we want. So and then the same thing for the y. Okay. And now what we do now here is that we will compare this new integer position, that is it different than before. Okay. Okay, so if where's the head? New head position. Okay, so I can use that one. Okay, so if the old head x is different than the new x, or actually I have a function already which is checking the I have a function for the, maybe I'm using it, where is it? Here I have already this function. Let me create a not equal, that will be not this equals the point. So now we can check inequality also for the point. Okay, so if this back point is not equal with point x xy, if the new point is not the same as the old head point, that means that that means that we moved that we are moving. That means what does that mean? This means that we are moving, we are about to move. Okay, then I guess I can check that did we move same direction or different direction. How do I check that? We are going same direction. Oh, we know that because we can compare it to the old direction. Because this is the old position. Yeah, and this is the new position. Yeah. But how do we know? I'm confused myself. Maybe it's time to actually I need to go now. Actually, in a couple of minutes I have another work here, so actually I will think about this. I'm actually gonna continue this video probably. I will actually think about this, and then I think I'm gonna start another video soon. Not soon, but later today. I will think about this actually, and then when I have the solution I will probably start a new video here. Okay, I need to go now actually, but I might come back later today. Okay, thank you everybody, and see you soon.